we are going to look at how to get probabilities from a probability distribution having been formed. And in this case, I want to use at example 1, using a probability distribution to find probabilities for specified ranges. Dear viewers, we can begin with an example. As you can see that the discrete random variable x has the given probability distribution, and we said discrete random variables have values which are discrete or which are countable or which can easily be specified. And as you can see, x has values defined from 1 up to 5. So we don't consider fractions for a random variable x. Then these are the probabilities. And you want to use this probability distribution table presented to us to get the probabilities in a specified range, and possibly we shall move on to look for the range and the mode. Now, here comes the question. We have values 0.2, 0.25, 0.4a, and 0.05. These are probabilities assigned to each and every x value. But you can see that 4 is assigned a value a, which is supposed to be found. And clearly, we shall use the property that we looked at, that when you add probabilities for all values of x in the given range, we should get 1. Therefore, these probabilities will be added, and we shall have 0.2 plus 0.25 plus 0.4 plus an unknown a plus 0.05, and this one will be equal to 1. So these probabilities in the table are added simply together and equated to 1, so as we fulfill this property of ours, and we shall have a plus 0.2, 0.25, that is 0.45, 0.85, 0.9, and this will be equal to 1, and a will clearly be equal to 1 minus 0.9, and it will be 0.1. So the value of a is supposed to be 0.1. And since this is a probability distribution function, we can use it to draw vertical lines to illustrate this distribution. And in simple terms, we can have a graph with the vertical axis and horizontal axis, where on the horizontal axis we shall have x values, on the vertical axis we have our probabilities, like the way we have x and y axis. And clearly values of x are all positives, therefore we can have 1 equal ranges 3, 4, and so on. And the probabilities, the highest is 0.4, and therefore can have 0.1, 0.2, 0.3, 0.4, 0.5, and so on. So this can be our graph. Then we go to plot vertical lines. 1 corresponds with 0.2, so 1, 0.2, and get a ruler, join with a vertical straight line. Then 2, 0.25, which is between 0.2 and 0.3, which is there, draw a vertical straight line. 3, 0.4, draw a vertical straight line. Then we have 4, it is A, which is 0.1, to be like that. Then 5, 0.05, which is half of 0.1, and it will be there, and this will be a vertical straight line. From the graph, it is very clear that the tallest line is when x is equal to 3, and clearly it corresponds with the highest probability. So, and our questions, they are telling us to calculate mode, and we define mode. Mode is the value of x which corresponds with the highest probability, and therefore mode as the highest most probable number is the mode, and the value of x will be the mode. For instance, from the graph, the highest probable number, the highest probability is 4, 0.4, and it corresponds with x equal to 3. Therefore, you say mode is 3. Mode is 3 because it is the value of x whose probability is the highest. Now, back at our question, we are using the distribution function to get probabilities for the specified ranges. For instance, we have to look for probability of x values between 1 and 3 inclusive. This inequality means that 1 and 3 are part of the range, they are inclusive, and therefore the solution will be probability of x equal to 1 because 1 is part, and probability of x equaling to 2, and probability of x equaling to 3. So between 1 and 3 we have whole numbers 1, 2, and 3. We don't consider fractions when it comes to discrete random variables. We consider whole numbers, and therefore between 1 and 3 inclusive we have 1, 2, and 3. Now, probability of x equal to 1 is clearly given as 0.2. Probability of x equaling to 2 in the table 0.25. Probability of x equaling to 3 0.4, and when this one is totaled up, it will give the answer as we estimated 0.85. Therefore, probability of x values between 1 and 3 is 0.85. Now here comes Roman 2, where they request us to look for probability of all x values greater than 2. X values greater than 2, we have 3, we have 4, we have 5, depending on the question. So more than 2, we have 3, we have 4, we have 5. But you know there are very many values which are more than 2, but in this case our table is giving only 3, 4, and 5. So we ignore the rest. fractions not required. And therefore, more than 2, we have x equaling to 3, which is 0.4. X equaling to 4, it is our 0.1 at the value of a. X equaling to 5, 0.05, and it gives the answer 0.55 as we anticipated. 0.55 as probability of x more than 2. Now, look at Roman 3, probability of x between 2 and 5. Between 2 and 5, as you can see, 2 and 5 are not inclusive. Check the inequality, and therefore between 2 and 5, we can say that we need the probability of x equaling to 3 and probability of x equaling to 4. That is the probability of x values between 2 and 5. 2 and 5 are not part of the range given, and therefore you consider values in between. And these values must be whole numbers. Therefore, we shall have x equaling to 3 in the table 0.4. X equaling to 4 is 0.1, which is our A, and automatically this will give us 0.5. So this is how we look for probabilities when you have the distribution function. Probability of exact values is also there, like probability of x equaling to 2 is 0.25, probability of x equaling to 3, 0.4, and so on. And therefore, that's how we go about it. Please remember that mod is the value of x which corresponds with the highest probability. Look at the probabilities you have in the question. The biggest probability, we say the value of a is 0.1, and the highest probability is 0.4. Therefore, the mod is 3. That is our first example. Viewers, I want to introduce you to example 2, where the question says the random variable x takes integer values, and these integer values, you can see we are run from 1 up to 9. These are integers. We can even have negatives as long as they are integers, whole numbers, integers. Therefore, it has a PDF, as you can see. K is a constant, and we can attempt this question. As we can see, we can draw a table of x, then probability of a random variable x equaling to a specific value of x. So we use small x because small x stands for a specific value, then capital X stands for that random variable. That random variable is general, standing in for particular values x small, and therefore, as you can see, x runs from 1 up to 9. So shall run from 1 up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 without skipping any. And we go back to the question. Probability of x equaling to 1 is substituted here where there is x, and when I put here 1, it becomes k. So we shall have a constant k. When you put 2, it becomes 2k. When you put 3 here, it becomes 3k. When you put 4, it becomes 4k. When you put 5, it becomes 5k. But when it comes to 6, the function changes to k brackets 10 minus x, therefore 6 is substituted here. Please note that 6 is substituted here. Don't make a mistake and you continue, because this first function is only defined for x ranging from 1 up to 5. When it comes to 6, then the function branches to k into 10 minus x. Therefore, when I put here 6, it becomes 4k. 10 minus 6, that is 4k. When you put 7 here, it becomes 3k. When you put 8, it becomes 2k. When you put 9, it becomes k. And this is the way how our table will look like. Therefore, when these values are added, we shall have 25k when all these values are added. But we know that the sum of probabilities for all values of x without skipping any should give us total of 1. Therefore, 25k should be equal to 1 divided by 25 divided by 25. K will be equal to 1 out of 25. Now, since we want to get probabilities, we shall be able to have a column of complete values, such that since we got k as 1 over 25, where there is k, we put 1 over 25, and we shall have 1 out of 25. 2 times k, that is 2, 25, 3, 4, 5, then 4, then 3, then 2, then 1. So these are our probabilities without an unknown, and this is the column. When you go to questions, probability of x equaling 4, go in the table and see where there is 4, its probability becomes 4 out of 25. Then probability of x ranging from 3 to 7, that means we need values of x from 4, then 5 and 6, because between 3 and 7 are not inclusive. Therefore, we take on values which are in the middle of 3 and 7 and they are integers only. And the probability of x equaling 4 is 4 out of 25. Then probability of x equaling 5 is 5 out of 25. Then probability of x equaling 6 is clearly 4 out of 25. When these three probabilities are added together, we shall say that 4, 9, 13 over 25 will be our output, and that's how we get the probability. Probability of x greater than 7. According to our question, values of x greater than 7, we have 8 and 9. So probability of x more than 7 means we have 8 and 9, and the probability of x equaling to 8, that will be 2 out of 25. Then that of 9, it is 1 out of 25, and the sum will give us 3 out of 25. So viewers, that's how we can get probabilities when given a distribution table, or you can even form it as you can see. Suppose that the question was find the mode. You look at your probabilities and you check which one is the highest. As you can see, the denominator is uniform, 25. So when you start from here, we look at the numerator which is bigger. 1, 2, 3, 4, 5, 4, 3, 2, and this one possibly 5 out of 25, which is when reduced it becomes 1 over 5 or 0.2, seems to be the highest probability according to our values in the table, and that corresponds with x equaling to 5. This should be your mode. The mode is the value of x whose probability is the highest. So that's how we can go about this specific question. And please try to follow without making any error. It is very important. Now we can look at example 3. The discrete random variable x takes values 3, 5, 6, 8, and 10 only, given that probability of x equaling 3, 0.1, x equaling to 5, 0.05, x equaling to 6, 0.45, x equaling to 8 is 3 times that of x equaling to 10. Find probability of x equaling to 10 hence. So we can still form a distribution table for this question, and since you know that we have x and its corresponding probabilities, and clearly x runs from 3, 5, 6, 8, 10. So x takes on values which have been selected for you, and we have 3 whose probability is 0.1, we have 5 whose probability is 0.05, then probability of x equaling to 6 is 0.45, then probability of x equaling to 8 is not known but is 3 times probability of x equaling to 10. So we may assume that probability of x equaling to 10, if takes on value say p, small p, then 8, probability of x equaling to 8 is 3 times p. Because if 10 takes on p, then the probability of x equaling to 8 is 3 times that of 10. And clearly, we shall be able to add using our first law or rule that when these probabilities are added together, then you should be able to get 1. And when you add, this will be 0.15 plus 0.45, which will be 0.6. Then 3 plus p, that is 4p. But now this sum of ours should automatically be equal to 1. And this one should imply that 0.6 plus 4p should give us 1. 4p will be 1 minus 0.6, and 1 minus 0.6 it is clearly 0.4, and our 4p is equal to 0.4 divided by 4, and p becomes 0.1. Therefore 10 will automatically be equal to its probability 0.1, then 8 will be 0.3, and these will be the real probabilities for 8 and 10. and therefore after you have filled up this distribution table, you can use it to attempt any given question. For instance, if they say find probability of x equaling to 10, probability of x equaling to 10, it is very clear that it is 0.1. Probability of x greater than 2.5, as you can see, find probability of x greater 2.5. 2.5 is not a whole number. We cannot round off, but we look for values of x which are above 2.5. And therefore 2.5 values above 2.5, from the table we have 3, we have 5, we have 6, we have 8, and we have 10. Therefore that takes up the whole of the probability of the possibility space given, and that will be equal to 1. So probability of x more than 2.5 is equal to 1, because all values that you have satisfy the condition. Thank you for listening.